On page 924 is where we're going to start. Okay? And this is not graphic. Okay, what we're going to be doing is I'm going to be giving you some identities that some of them you kind of already know and whatnot. And what they're going to do is they're going to give you some things and it's just going to say simplify. Reduce it as much as you can. The first identities that we're going to talk about are the reciprocal identities. And the first reciprocal identity that they have is that they have the cosecant. You haven't seen that word in a while. Is equal to 1 over the sine of theta. Now, you knew this already. Why did you know this already? When did we talk about the reciprocal stuff with cosecant and sine? That was in the last chapter. That was in chapter 13. Remember when we were coming up with all those different things from the right triangle and from the unit circle? Absolutely. So if I gave you secant, what's the reciprocal of the secant? You guys remember what the reciprocal of the secant was? The cosine one. And the last one, if I asked you for cotangent, what's the reciprocal of the cotangent? 1 over the tangent. Right. Okay, so those are the reciprocal identities. All right? And we're going to use those and help us simplify some things down. We're going to be doing some multiplyings of these things together, and when you have something with like one on the top, one on the bottom, they can reduce. Okay? The next ones are known as the tangent and cotangent identities. Okay? What I'm going to do, just so that you guys know, is I'm going to give you all of them first and then go through some samples, just so that you guys know. So I've got the tangent of theta is equal to the sine over the cosine. Which you guys knew that already. We had it last chapter. But then the cotangent, remember how we said that the cotangent was the reciprocal of the tangent? So what's the reciprocal of sine over cosine? Cosine over sine. Right. And then the last ones that we're going to deal with, and the reason why, and if you're on page 924, and if you see that there are some other ones, just so that you guys know, because of the Common Core stuff, we don't deal with cofunctions and we don't deal with negative angles. So the first three, reciprocal, tangent, cotangent, and Pythagorean, are the only ones that we deal with. Sine squared theta plus cosine squared theta equals 1. Why do you think they call it Pythagorean identities? Because of the square, like a squared plus b squared equals c squared? Okay, it's kind of that same kind of concept. Then they have 1 plus the tangent squared theta equals the secant squared theta, and 1 plus the cotangent. Okay, so those are the ones that we're going to use. So we're going to use the reciprocal ones, we're going to use the tangent, cotangent, and we're going to use the Pythagorean ones. Okay, that's what we're going to do. All right. So here's what they're going to have you doing. Okay, use my book. Okay, so if I've got the sine of x times the cotangent of x times the secant of x. And what they're going to ask you to do is they're going to ask you to simplify this. Okay? So if I multiplied all those together, first of all, sine, cotangent, and secant, none of that's the same. So let's try to get it in the same terminology. Let's try to get them down into like sines and cosines. So that way maybe something crosses out. The cotangent I gave you in the second set of things with the tangent and cotangent identities. What was the cotangent equal to? Cosine over sine. So I have the sine of x. And now what I'm going to do is I'm going to replace, or I'm going to substitute that cosine over sine in for cotangent. So this is now going to say the cosine of x divided by the sine of x. So I replace the cotangent with its identity. Does that make sense?
Yeah.
What was the secant equal to?
Secant equal to 1 over cosine of theta.
1 over the cosine. Now on this particular problem, we're using x instead of theta, but that does not matter. So what I've done is I've taken and I've replaced those cotangent and secants with their identities. Now, this is nothing more than you trying to cancel or cross out or reduce fractions, whatever you want to call it. So, Katie, if I put sine x over 1 at the beginning, do I have a sine x on the top and a sine x on the bottom somewhere? Absolutely. So this goes away. If you have one on top and one on bottom, gonzo. Is there anything else that I can cross out? What, Hannah? The cosines. Now, if you didn't notice, I crossed out everything.
Except for the ones.
Except for the ones, which when I cross out the ones that I did, those become ones. Because if you have something divided by itself, you should always get 1, not 0, which is what a lot of people think. So if I have a bunch of 1s, if I take 1 times 1 times 1 divided by 1 times 1 times 1, what do I get? 1. And you're done. This is what you're going to be doing today, is you're going to be taking these things that have been multiplied like this, rewriting them in terms of sines and cosines, and then reducing if you can. Okay, let's look at another one. Okay, anyway, so here's my problem. Let's start with the top. What was the tangent ratio equal to? Sine over cosine. So if I replace that with sine over cosine multiplied by, what was the secant equal, or cosecant, I mean? 1 over sine. Uh-oh. And then on the bottom, what's the secant equal to? Okay. Should be 1 over cosine, right? Fallon, do you want to deal with the top first? Or do you want to get rid of the bottom and just have one big giant problem? Do you want to get rid of the bottom? Okay. Fallon, last week we had something where it was like 2 pi divided by 1/5, and you said to flip and multiply by the reciprocal to make it 10 pi. What do you do here? What is the reciprocal of 1 over the cosine? Good. So now if I do that to 1, I got to do it to the other. The bottoms cross out. Weird. So Is there a sign on top and a sign on bottom? Ba-da-da-da-da-da. Ba-da-da-da-da-da. Is there something on the bottom and top that also match? Yep. Ba-da-da-da-da. Ba-da-da-da-da. And what do I got? 1. Again. Weird. Is it always going to equal 1? No. It just so happens to be the first two that I did. Okay?
Wait, so you did over 1 over what?
Wait, so how do we do these with numbers?
1 over sine. 1 over 8. Like, 1 over sine. What is cosine of 1?
Okay, so let's take a look at this one. Look at the identities I gave you. Did I give you one of those? Cosine's not going to change. Did I give you 1 plus the tangent squared theta? What is it? Secant squared. Woo! So I got the cosine of theta times by the secant squared of theta.
Times 1 plus tangent.
No.
Oh, you're just...
I replaced it.
Oh, okay.
I used substitution.
You replaced the identity with the actual...
Okay. This 1 plus the tangent squared of theta is one of the Pythagorean identities that I gave you. So all I did was I took this out and put this in its place. That's all I've done. That's part of the identity found. So in that part, when it said, if you look at the Pythagorean one that I gave you, it said 1 plus the tangent squared theta equals the secant squared theta. Now, does anybody know what the secant is equal to? 1 over cosine. So if I did that, if I had the cosine of theta times by, since it's secant squared, 1 over the cosine squared, right? Since I was squared. Now, I have 1 cosines on the top. I have 2 cosines on the bottom. Who has more, top or bottom? The bottom. By what? 1 cosines, right? One of the identities, the reciprocal identities that they give you is secant. The reciprocal of secant is 1 over the cosine. Okay? And Noah, since it was squared, so was this. Okay? Now, because there's 1 more on the bottom than there was on the top, I cross out the 1 on the top, and there's 1 left over on the bottom. So what do I have left?
1 over cosine.
1 over cosine, which, if I remember right, using the reciprocal identities, 1 over the cosine is equal to just what? The secant of theta. I have simplified it. You're simplifying. It's not as hard as it looks.
I'm pretty sure you're making this up.
No, I'm not. Why would I make anything up? To simplify it. That's the goal. That's what you got to do. Oops. Better use the same terminology. Right, McKenna? Yeah. Okay, let's take a look at your identities that I gave you. Cotangent. was equal to what? We had 1 over the tangent, but also what else do we have? Cosine over sine. Okay? So instead of writing it as 1 over the tangent and then taking that and doing the same thing, the reason why I'm going to go with that second one is because I have cosine in play right now. So I have the cosine of squared x over, what did you say the tangent was? Or cotangent? The cosine squared over the sine squared. Why would they be squared? Because it was squared. Right. Since this number was squared, right here, and so are these. Now, Fallon just told us not too long ago, in order to get rid of something on the bottom that's a fraction, we've got to multiply it by its reciprocal. Right?
Right.
So what's the reciprocal of cosine squared over sine squared? Sine squared over cosine squared. So here's what's going to happen. We got the cosine squared x, which is the top, multiplied by the reciprocal of the bottom, which is sine squared over cosine squared. Now, I'm pretty sure you guys are, those are, so where is the,
Looks like a perfect one.
on the bottom?
On the top.
Where at?
Like cosine.
Is there anything that crosses out?
Cosines.
Yeah, both cosines. Beep. And what are you left with?
Sine squared.
The sine squared. Now, looking at all that different in that material, when you have the sine squared like that, there's nothing else you can reduce that down to. Right? Because otherwise, if you had all those identities, you'd have just a bunch of, if it was 1 over the sine squared, then we could do something. But we're trying to get it so that it doesn't have fractions anymore. You guys don't want to cross off fractions?
Yeah, I'm enjoying this more than the graphics.
Alyssa, what? Okay, I got rid of the cotangent by replacing it with its identity. And then from here, I multiply by the reciprocal. And then you're just trying to cross things off. All you're trying to do is simplify it. That's it. Do you want to do another one? Yeah? Okay. Huh? We have been. No. Should do what? Huh? Which one? No. Those are both negative angles. Not going to do those. No, they're not part of that stuff, so we're not doing negative angles.
Are we just doing 10 through 21?
Yeah, but even some of those don't count because we're not doing negative angles. So the ones that have negative in the inside, like, see how it has sine of negative x in the bottom?
Yeah.
Cross it out, doesn't count. What about the 21? How it has negative x inside the tangent squared? Cross it out, doesn't count. We're not doing negative angles.
So 15 and 18 or 11.
Well, 15, if you look at 15 is a co-function. So that's got pi over 2 minus the whatever. So on that particular one, let's do 15. Yeah, this one's pretty easy. You guys are loud today.
I know, and it's not even me.
Okay, one more. On page 924, there was a chart that had this in there. Can anybody look at that chart and find where it says cosine pi over 2 minus the angle? And what is that equal to? The sine, and that's it, right? Okay, so now I've got the sine of x over the cosecant. I always want to put theta. So what I've done is I've taken what Hannah told me, and because it had pi over 2 minus the angle, that whole thing just replaced. What's cosecant the same as? 1 over the sine. Just the cosecant. How do I get rid of a fraction on the bottom? What's the reciprocal of 1 over sine? Sine over 1. And if I do that to the top, what's sine of x times the sine of x? Sine squared.
We're good. Leave it alone, Ellie.
Mm-hmm.
How did you get the sine x right away?
How do I get where?
It was there.
Oh, how do I get, okay. From here to here. That's what you want to know.
Where did the cosine go?
Oh, it's in both.
In or on page 924, it's one of the co-function ones. Okay? On that one, it says on that one, when you have the cosine of pi over 2 minus the angle, that's actually equal to the sine of x. Then some of the other ones that they have, the sine of that equals the cosine, and the tangent equals the cotangent.
Yeah, I thought you said we weren't using the function ones.
Sine of x times sine.
Of x. And the
Lied to me.
where was there a theta? You know what I did, Hannah? I started writing theta. I went, oh shoot, I always do that, and then I erased it, and you probably didn't see that. What do you think?
I thought you said we weren't using the co-function ones.
Yeah, well, I lied. That was easy. They're all easy, actually, except for I won't give you the ones like the negative angles. So you can cross out 20 and 21. Do you want me to do another one? No? Okay, here's what I want you to do. This is unheard of for you guys. So on page 928,
Alright, so we're not doing
so we can go 10 to 19.
pick 5.
Yeah.
That's a no one. That's a new one. I like that. I'm feeling it.